Hey, what is up? It is Tuesday, March 29th, 2022, and I am ready to tackle a classic coding problem, the longest substring without repeating characters. This is probably one of the most popular problems on Leetcode, and I guess with good reason, because it is one of those problems where when you get the efficient solution, you feel like $1,000,000 when you get the efficient solution without just relying on your algorithmic knowledge versus kind of memorizing the solution or whatever. So let's get into it. And also, the other reason why this, let me just step back. The other reason why this is a really popular problem, I think, is because some variant of it is asked quite often in interviews to see if you kind of understand the use of efficient iteration techniques rather than nesting loops into loops into loops. So let's go through the problem and then we'll get to how the solution works. So, given a string S, find the longest substring without repeating characters. And I like how short the statement of the problem is. And here's the example. So if you have A, B, C, A, B, C, B, B, A, and you want to find the longest substring without repeating characters, your answer is 3, right? And so why is that the case? So you have A, B, C, so it's 1, 2, 3, so no repeating characters yet. 4, which is A, and there's a repeating character there, so the longest substring found so far is 3. And then you start again. You have A, B, C. The longest substring found so far without repeating characters is again is still 3. And then you have a B, B. Okay, so at this point, you can see that the longest substring overall for this entire string is ABC. So the thing is, this is tricky because you can. Let's first talk about the kind of inefficient way of solving this, right? The inefficient way of solving this is pretty much look for every single substring, like do a double for loop, iterate every single substring within this loop, and so you can have A is a substring, AB is a substring, ABC is a substring, ABC A, ABC AB, ABC ABC, ABC ABC B, ABC ABC ABBC BB is a substring. Then you also have to start at B, so you have BCA, no, you have B, BCA, BCAB, BCABC, BCBBB. Then you have CA, CA, CAB, CABC, CABC, So that's the thing. You have to kind of create these like nested windows of checking every substring. Very, very expensive because you also have to check whether every substring has a repeating character, so that's at least you have a polynomial time algorithm here. Okay. Now, the question is, can we prevent ourselves from having to do that? Can we do less work here to check whether there's repeating characters? Do we have to check every single possible substring? Or can we just cut out a bunch of substrings because we know that there's already repeating character information there? So the answer is yes, we can do that, and that's what I'm going to do now. So basically, think about it this way. If you have A, B, C, A, okay, we'll use the first example. A, B, C, A. At that point, you know that you have, at that point, the condition, your invariant, breaks down, right? And that means that you have a repeating character. So in order to the right of me, I have more characters to check, but to the left of me, the condition broke down as soon as I hit A. So what does that mean? That means that if I should have a pointer where I should be able to just get rid of A, right? That first A. So I can leave this A out here, and then I can just continue checking. So if I have A, B, C, A, B, at this point, I can leave the C out and check CAB, right? And then again, so on and so forth. I'll extend it again, CABC. Whoops, condition broken again. And so this is kind of how the window slides. You keep sliding one to the right. Oops, and then at that point, now here's the tricky part. You have to keep sliding this, right? You can't just keep extending this right window without sliding the left window. You have to slide the left window, left pointer, until the condition holds again. So how can you check this condition quickly? Because you don't want to like do another internal loop in here to check whether the condition for the left window pointer holds. So you just have a hash set, right? Hash set, and you can check in O of one time whether this CABC, whether this B is contained right away already, and you just keep extending this window to the left until that's no longer true. So yeah, let's see if we can code this up and if this makes sense. So I'm going to start. As I said, I'm going to have a left window and I'm going to have a right window. Right equals 0. And because I'm looking for the longest substring found so far, I'm going to find many intermediate substrings. I'm going to have a longest window there. Then I'm going to, as I mentioned before, have this hash set here, because this is what I'm going to use to contain on each iteration of left and right, whether the left window or the right window pointer, they both point to something that is substring that has duplicates in it. The set will, remember, automatically eliminate duplicates, right? That's what a set does. It only contains unique values, even if you put in duplicate values. So length. So now what I'm going to do, remember I said we're going to iterate until we get to the end of the string, right? So if set contains, bear with me now, I'll explain this in a second. So here, what I'm doing, I'm checking on each iteration whether the set that I've created above contains the character, right? So if the character is not contained, then I will add that character to the set. I add this new character to the set, right? Then I increase the right pointer, because at that point I'm done with the right pointer, right? And at that point I check the longest, and the longest is simply the difference between the right and the left window, right? And longest, and you're checking what's the max there. Now, in the else condition, right, as we move to the left, the set needs to, if it contains the character, the set needs to shrink car at. The set needs to shrink by the left character, right, because we move to the left, and so we check the left, and then we increment the left character because we ignore that left character, and we continue to extend the right. By doing that, we can continue moving the right pointer and also not having to worry that there's duplicates not accounted for, because the condition breaks as soon as a duplicate is found. And as soon as that duplicate is found, we then contract the left side of the window, right? So let's see if this works. Okay, cool, accepted. And let's run the program, and bam. Okay, so I could have probably optimized this. I bet if I do my little trick of, let's try it out. Int longest, the set equals new int and int z plus 1, okay, because we're checking if any of the characters are contained. We do set equals 1, and to remove, we turn this to set equals 0. All right. Let us hope this speeds this up somehow. We also have to change this. Let's just do this. Okay. Let's see. Oops. Let's increase the size of this. Let's make sure I didn't. Let's try. Why is that? Okay. I'm going to. I have to include all of the characters. So let's try Z like that. Let's try. Just for now, I'm gonna try 200. Okay, now, wow, look at that. That's way faster. Okay, so that's just because the ASCII characters, right? We need to make sure we can encompass all the ASCII characters. Okay, so that's my solution. I hope you enjoyed that problem, and like, subscribe, and comment on the link below if you like this video, and let me know what I'm doing wrong. Let me know what I'm doing right, and I'll see you next time. Bye.